Elon Musk's latest post on X about Tesla's massive Terafab facility has drawn attention for its enormous scale and the army of Optimus robots. But the most revealing detail wasn't the factory itself, it was the appearance of the Robovan, the box-shaped autonomous vehicle that first stole the spotlight at Tesla's We Robot event. Its unexpected appearance has sparked an intriguing question. Could Tesla be much closer to putting the Robovan into production than most people realize? Only days later, Tesla reinforced that message in a more concrete way. According to information shared by @tslaming on X, the company was officially granted U.S. design patent after originally filing the application in October 2024, shortly after unveiling the Robovan. The patent credits Tesla's chief designer Franz von Holzhausen together with Julian Bilodeau, Ian Kettle, and Joseph Robinson. Unlike utility patents that protect engineering innovations or autonomous driving systems, this filing protects something equally valuable: the Robovan's visual identity. At first glance, protecting the exterior of a concept vehicle might seem like a routine legal procedure. In reality, design patents have become increasingly important as products evolve into recognizable brands themselves. The patent illustrations immediately reveal that Tesla is not trying to build another electric bus. Nearly every existing electric shuttle on the market, from the Ford E-Transit to the Mercedes-Benz E-Sprinter or countless Chinese electric minibuses, still follows proportions inherited from vehicles originally designed around combustion engines. They feature long front sections, conventional windshields, exposed wheel arches, and layouts that prioritize the driver's position. The Robovan abandons those assumptions completely. Rather than looking like a commercial van, the patent presents what can best be described as mobile architecture. The vehicle resembles a futuristic lounge or an autonomous transit capsule more than a traditional people mover. Instead of separate body sections connected together, the roof, side panels, and lower body merge into one continuous volume. There is no obvious hood, no protruding nose, and almost no interruption in the overall shape. The result is a seamless exterior that feels closer to a piece of modern architecture than an automobile. This design is not simply about aesthetics, it reflects a completely different engineering priority.
So this can carry up to 20 people, and it can also transport goods. So you can configure it for goods transport within a city or transport of up to 20 people at a time. So this is the Robovan is what's gonna solve for high density.
During Tesla's We Robot event, Elon Musk stated that the Robovan could eventually carry up to 20 passengers, roughly 10 times the seating capacity of the two-seat Cybercab. Once passenger capacity becomes the primary objective, maximizing interior volume becomes far more important than preserving traditional automotive proportions. Every inch occupied by a hood, engine compartment, or driver's cockpit is an inch that cannot be used by passengers. By treating the entire body as one unified architectural space, Tesla can dedicate almost the entire vehicle footprint to usable cabin volume. The patent drawings reinforce this philosophy. Large vertical sidewalls, a tall roofline, and nearly upright front and rear surfaces maximize internal space while keeping the exterior footprint relatively compact. This is the same principle used by high-speed trains and modern metro systems, where efficiency is measured not by horsepower but by how many passengers can be transported within a given length of vehicle. Another fascinating aspect of the design is its clear inspiration from Art Deco transportation. Instead of adopting the sharp geometric styling that defines the Cybertruck, the Robovan embraces smooth curves and continuous horizontal lines. Rounded corners replace aggressive edges, while the body flows uninterrupted from front to rear. This influence is far from accidental. During the 1930s and 1940s, streamlined locomotives such as the Burlington Zephyr and luxury intercity buses used Art Deco styling to symbolize technological progress. Their curved bodies reduced visual complexity while creating a sense of effortless movement. Tesla appears to be borrowing the same philosophy for the autonomous era. Rather than making the Robovan appear intimidating or mechanical, the flowing design communicates calmness, sophistication, and accessibility, qualities that are particularly important for public transportation where passengers must trust a vehicle operating without a human driver. Perhaps the most unusual design element is what the Robovan deliberately removes. There is no grille because there is no internal combustion engine requiring airflow. There is no hood because there is no front-mounted engine. There are no side mirrors, consistent with Tesla's long-term reliance on camera-based perception. Most significantly, there is no obvious driver's compartment. That change represents one of the most fundamental shifts in automotive design since the invention of the automobile itself. Traditional vehicles are built around the needs of the driver. Tesla's Robovan is built around the needs of everyone except the driver because ultimately there isn't supposed to be one. Another defining feature of the Robovan is its fully enclosed wheel architecture. Unlike traditional buses or vans where large exposed wheels dominate the lower body, Tesla pushes the wheels and suspension deep underneath the vehicle and covers them with smooth body panels. The result is a silhouette that almost appears to float above the road like a hovercraft. This is more than an artistic decision. Exposed wheels are one of the largest sources of aerodynamic turbulence on any road vehicle. Engineers estimate that the wheel area can contribute 20 to 30% of a vehicle's total aerodynamic drag, depending on speed and body shape. Tesla has always treated aerodynamic efficiency as one of its biggest competitive advantages. The refreshed Model 3, for example, achieves a drag coefficient of approximately 0.219 CD, making it one of the most aerodynamic production sedans in the world, while the Model S remains around 0.208 CD. Although Tesla has not released any aerodynamic specifications for the Robovan, enclosing the wheels follows the same engineering philosophy. Lower drag translates directly into lower energy consumption, longer driving range, and reduced operating costs, critical advantages for an autonomous vehicle expected to remain in service almost continuously throughout the day. Another striking element highlighted by the patent is the continuous glass canopy surrounding the upper portion of the cabin. Instead of dividing the side windows with thick pillars and conventional frames, Tesla wraps a dark glass band around almost the entire passenger compartment. The curved ends of the glass soften the vehicle's proportions and visually reduce its massive size. From an architectural perspective, this creates the illusion that the roof is floating above the body. The technique is frequently used in modern architecture to make large buildings appear lighter, and Tesla applies the same principle here. Despite being considerably larger than a passenger car, the Robovan avoids looking bulky or intimidating. Instead, it projects openness and accessibility, qualities that are particularly important for a vehicle designed to carry dozens of passengers. Large panoramic glazing also serves a practical purpose. Studies in public transportation design have consistently shown that passengers perceive vehicles with larger windows as being more spacious, safer, and more comfortable. Natural daylight reduces feelings of confinement, while better outward visibility can improve the overall passenger experience during longer journeys. Tesla appears to be treating the Robovan not simply as transportation, but as an environment where passengers may spend significant amounts of time. The patent drawings also reveal a series of horizontal layered bands running along the side of the vehicle. While Tesla does not specify their exact function, these parallel lines likely serve multiple purposes. Visually, they break up what would otherwise be an enormous uninterrupted body panel. Functionally, they could eventually integrate full-width LED lighting, turn indicators, autonomous communication signals, or aerodynamic trim pieces. This would be consistent with Tesla's recent design direction. The Cybercab introduced continuous front and rear light bars rather than conventional headlights, while the latest Tesla vehicles increasingly use lighting as part of their visual identity. As autonomous vehicles become more common, external lighting may evolve beyond simple illumination to communicate vehicle status to pedestrians, cyclists, and other road users. The Robovan's horizontal architecture appears perfectly suited for that evolution. The overall proportions of the Robovan also reveal a clear emphasis on space optimization. Unlike conventional passenger vehicles, which often sacrifice practicality for sporty styling, the Robovan maximizes every possible cubic inch of usable volume. The front and rear are almost perfectly vertical, while the side walls extend nearly the full width and height of the vehicle. This box-like architecture allows Tesla to create a remarkably spacious cabin without dramatically increasing the vehicle's external dimensions. That approach is reflected in the interior renderings accompanying the concept. Rather than rows of tightly packed seats similar to a traditional city bus, the Robovan features an open cabin with lounge-style seating, wide aisles, generous legroom, and panoramic windows. The atmosphere resembles an airport lounge or premium train carriage far more than conventional public transportation. Tesla also appears to prioritize flexibility over fixed seating arrangements. The spacious interior could be configured for airport transfers, employee shuttles, urban transit, autonomous ride-sharing, or premium mobility services depending on operational requirements. Because there is no driver's cockpit occupying valuable floor space, almost the entire cabin becomes available for passengers. The patent illustrations further suggest that Tesla has considered cargo transportation alongside passenger service. One rendering shows a dedicated luggage compartment integrated into the rear lower section of the vehicle. Separating luggage from passengers improves comfort while allowing the Robovan to serve multiple purposes, including airport transportation, hotel shuttles, commercial logistics, or autonomous package delivery. This versatility aligns closely with Elon Musk's previous comments that the Robovan is intended to transport both people and goods, expanding its usefulness far beyond traditional public transit. Perhaps the most fascinating aspect of the patent is how intentionally different the Robovan is from the Cybertruck. Although both belong to Tesla, they communicate completely different personalities. Cybertruck emphasizes strength through exposed stainless steel, sharp geometric surfaces, and aggressive industrial styling. It is designed to project durability and toughness. The Robovan does exactly the opposite. Soft curves replace sharp edges. Hidden wheels replace exposed mechanical components. Continuous glass replaces segmented windows. Flowing body surfaces replace flat steel panels. The result is what could best be described as a retro-futuristic public transportation aesthetic, one that combines the elegance of Art Deco streamliners with the simplicity of modern consumer electronics. Instead of looking like industrial equipment, the Robovan resembles a welcoming public space on wheels. Ultimately, the newly granted patent confirms that Tesla is protecting far more than an attractive exterior. It is protecting the visual identity of an entirely new transportation category. Cybercab is designed for individual robotaxi rides. Tesla Semi is intended to transform freight logistics. The Robovan occupies the critical space between those two products, offering high-capacity autonomous transportation for campuses, airports, factories, entertainment venues, city centers, and public transit networks. Its continued appearance in Elon Musk's Terafab vision, combined with Tesla's decision to secure legal protection for its design, suggests the project remains very much alive. The company may not have announced a production date yet, but the patent makes one thing clear. Tesla is already laying the intellectual property foundation for what could become one of the most recognizable autonomous public transport vehicles of the next decade.